Assalamualaikum. We are from Group 3 and the title of our project is Data Analysis of E-commerce Sales Patterns and Shipping Operations. Before we jump further into the details, let me briefly explain what e-commerce is and why it's important. E-commerce or electronic commerce refers to the buying and selling of goods or services through online platforms. In our research, we look at how e-commerce creates a lot of data like sales, shipping, and customer activity. This data helps businesses understand trends, improve operations, and make better decisions in a competitive online market. Now, let's look at the problem statement. E-commerce companies struggle to understand how sales performance and shipping operation affect each other. Without this understanding, they may miss business opportunities, face higher costs, and experience lower efficiency. By analyzing key data from both sales and shipping, companies can discover useful patterns and improve their strategies and also increase both profit and overall sales performance. And the target audience for our project are sales managers, marketing manager, and business executive and management.
Moving to the objective, Objective 1, to analyze sales performance and identify key trends of product categories, customer segment, and regional contribution. Objective 2, to identify the shipping pattern on product and delivery efficiency. Objective 3, to explore the relationship between sales and shipping pattern. For the project question for Objective 1, first is, what are the top 5 best-selling products? Second, do sales go up or down at certain time of the year based on daily trends? And the third, what are the highest sale for each product category? For the project question for Objective 2, first, what are the daily shipping trends of the orders? Is there any delay during the shipping time? And what is the average shipping cost for each product category? And the project question for Objective 3, first is, what is the relationship between sales and shipping period? And is there a link between order priority and shipping period by product category?
Next, we move to the methodology part. We use a dataset called e-commerce data from Kaggle. At first, it had 21 columns and over 51,290 records, but we removed 6 attributes as they were out of the study scope, and we used simple random sampling to reduce the data, which led to 15 columns and about 9,607 records left to analyze. In our analysis, we added 8 new derived attributes to the dataset. These attributes were created using the existing data to help us get more detailed insights. We also prepared a data dictionary to explain each column in our dataset, including the data type and a brief description of what it represents. So these are our EDAs, or exploratory data analysis, which help us understand and prepare the data before analysis. We use it to check the structure of the data, find missing values, detect outliers and spot patterns or trends. It also helps us create simple charts to see relationship between factors like sales, discount, or region. In short, EDA makes sure our data is clean and ready for deeper analysis. Here are our first dashboard, which represent the first objective. We look at the first chart, which is a line chart, to show a comparison by showing our daily sales trend. We can now see that sales were steady, but they dropped significantly at the end of the month. To understand what kind of products are driving these numbers, we explore the Sankey diagram, which is a relationship chart. It shows how sales are affected by product categories and discount. Clearly, fashion products like t-shirt dominate the flow and they are being sold under various of discounts. That brings us to the next question. Which type of customers are buying these products and at what sales range? To answer that, we look at the line and stacked column chart, where it is a comparison and composition chart showing sales range and profit by segment. Here we learn that most of our profit and orders come from 201 until 500 sales range, especially from the consumer segment. But are these sales happening evenly across all regions? So, the tree map, which is a composition chart, helps us to answer that. It illustrates the product quantity by region, where Central and East regions are leading in product quantity, especially in the fashion category. Finally, to wrap it all up, we look at a horizontal bar chart, which is a comparison chart showing the top 5 products sold. Again, t-shirts stand out, followed by watches, shoes, and jeans. This dashboard analysis suggests that fashion are the key drivers of sales, with strong performance among consumer segments in specific regions. Next, this is our second dashboard, which represents the second objective. The first chart is to explore the shipping cost by product category, which is a 100% funnel chart used for composition. It shows the average shipping cost across product category. Fashion takes up the highest and home and furniture the lowest. Since fashion is the best-selling product, it's logical that it carries the highest average shipping cost too. But does shipping activity match the shipping trend? So let's look at the daily shipping trend, which is displayed using a line chart. It shows that shipping activity is consistent throughout the month, but there's a sudden dip at the end. From trend over time, we dive into orders by ship mode, shown in a grouped bar chart, which is also a comparison chart. This chart shows that standard class dominates in quantity and shipping cost range, which are 0 to 3 ringgit. We then verify this performance with the on-time versus delayed chart, where a pie chart used for composition, where this chart can show the delivery efficiency. Overall, 96.59% of orders are still delivered on time, which shows the system is efficient. Finally, the quantity by delivery speed illustrated in the donut chart that is used for composition shows that although most deliveries are on time, 49% are delivered very slow. In conclusion, dashboard 2 shows that the fashion has the highest shipping cost and static class is the most used shipping mode. Most orders are delivered on time, showing strong efficiency, but nearly half are delivered very slowly, indicating a need to improve shipping speed.
Moving to the last dashboard that represents the third objective. The first is a scatter plot. It shows the relationship between product aging and sales value. We see that longer aging often mean higher sale because bulk or low priority order take more time but bring bigger sales. To see how this order dividing regionally, we look at the ribbon chart. It shows the comparison and composition of shipping costs across the region. We can see that central region come with the highest sale, with most shipping costs falling at 7 to 11 ringgit. Next, to break down which product category and delivery speed create this pattern, we look to the sunburst chart. This chart shows composition. Here we see that fashion contribute the most to slow and very slow delivery, matching the longer aging trend, while electronic and auto accessories sell more with fast delivery, matching urgent customer needs and higher shipping effort. Finally, to connect all these pieces, we have the Sankey diagram. This shows composition. The Sankey tie everything together, showing the flow from product category, order priority, and aging. We can clearly see fashion flows mostly into low or medium priority with longer aging, while electronic flow into high priority with shorter aging. Okay, before we end this presentation, we will show a demonstration of our e-commerce dashboard. For example, if we choose April and pick to the specific product category like fashion, then the output will change accordingly for all the dashboard. Okay, this is the result of dashboard 1, dashboard 2, and the dashboard 3.